Everyone is here?
Yes, sir.
Yes.
We are talking about hypothesis testing. Right now, I have opened an Excel file where plenty of data is available so that you can connect your the basics you learned in hypothesis testing to this. See, imagine you are MD of an hospital or you are the chief of the hospital. And in your hospital, there are 4 laboratories. And the data here represents the turnaround time of laboratory. You all know that, right? Turnaround time. So turnaround time is continuous data because time is measurable. Now your doubt is the 4 laboratories are performing the same test, similar test. Then turnaround time should be same or different?
Same.
Same.
Should be same.
Different.
Same laboratories, I mean similar laboratories performing similar test. What is our expectation? Turnaround time should be same. And so the statement that or equal. When I say that or equal, this is my null hypothesis. When I say that or equal, that is known as null
Null
hypothesis. The symbol for null hypothesis is H naught. Now what will be alternate? Symbol is H1.
That may be equal, may not be equal.
That's what, that or unequal. Or I can always say that of at least one of the lab.
Must be equal.
One of the lab is different. So these are all alternate. These are all called alternate hypothesis. All right. See now, the data is continuous. The data is continuous. And there are 4 laboratories we are trying to compare at a time. This is a hypothesis testing. Am I right? This is hypothesis testing. Yes or no? We simply believe that all the laboratory will consume the same amount of time to perform a particular testing. That is our belief. Our belief is null hypothesis. What we infer from the data is alternate hypothesis. My question is whether I can believe the data or not. If you, whenever you want to believe the data, you should be able to reject the null. If you are not able to reject the null, then there is no point of reading from the data. Right? So, in order to understand something, you performed experiment, you generated data. But what if data can mislead you? Data should not mislead you, isn't it? Whenever you understand data can also mislead you, it is better avoid using the data. That's the time we don't reject the null based on what we observe. Clear? Even though we observe something, sometimes we will prefer not to use the data, not to use the findings from the data. This is what is called don't reject the null. Clear, all of you? All of you are able to understand me? Definitely it is difficult, right? Because the statements are not direct, right? All right. So now your null hypothesis is sometimes true. Your null hypothesis may be true, but still, based on the experiment, you may reject it wrongly. Possible or not?
Maybe possible.
Possible.
This is called type 1 error. This is called type 1 error. Sometimes your null is false. You may still end up accepting the null. This is called type 2 error. All of you are able to understand?
Yes, sir.
Yes.
Yes, sir.
What is null? What you have been believing from the past so far. Whatever we have been practicing right now, that is null hypothesis. Yes or no?
Yes.
Your company believes in something, but you are the one, testing it, whether the company's belief is correct or not. In the process, you may succeed. In the process, you may sometimes fail also. Right? So if the company's belief is true, then your experimental, after conducting the experiment, you are supposed to align with the company's belief. Am I correct or not? If your company's belief is correct, what they believe is correct, what they practice is correct. If you do an experiment correctly, properly, your experimental outcome should actually align with the company's belief, because it is true, isn't it? If the company's belief is wrong, let's say the null is false. Now you are conducting the experiment. Company's belief is false, and your experiment also confirms that it is false.
False.
That's the time you will reject the null. That's the time you reject the null. Rejecting the null means you are now making changes. You are now making changes which are necessary. Am I right? The changes are necessary and you are making it. All of you are with me?
Yes, sir.
Yes, yes.
Sometimes your company's belief is true. You have done an experiment and your experiment conveyed the dead opposite. Now what do you do? Right? Now also, let's say, imagine null hypothesis is true, but you still reject the null. Now what are you doing? Now also you are making changes, isn't it? You are trying to make changes. But this time your change is necessary change or unnecessary change? You understand what I am typing now? You have done an experiment, you have seen something, but what you have seen is wrong. Possible or not?
Yes.
Possible.
Possible.
Possible. What I have seen is wrong. Maybe
Yes.
there are a lot of reasons behind, right? Sometimes data will get generated
Yes.
randomly also. We don't know. Sometimes, if we conduct the exam, we have noticed it. Some people, they just give the answer using a hinky-panky method. They still pass the exam. How they passed? Random chance, isn't it? We don't know. Am I correct?
Yes, sir.
Yes, sir.
Is there a possibility that things can happen on its own?
Yes.
No proper preparation, but then also without reading the question, we are selecting the answer. Then also there is a chance that we get a pass mark. So this is called random chance causing the event. Random data is generated. So if you believe that and then make changes, your change is an unnecessary change. As a professional, as a manager, you are supposed to make changes in the process only when it is necessary. Am I correct? And you are
Yes, sir.
never supposed to make unnecessary changes. Please see to that. Whether you make the necessary change or not, never make unnecessary change. They may even send you out otherwise, isn't it? Correct or not? Whether we make the necessary change or not. If we make one unnecessary change, there will be 100 people pointing fingers on you. Yes or no?
Yes.
Yes.
Yes,
So,
yes.
we should not do that. This is what in judicial system also called. 1,000 criminals can escape, but one innocent should not be punished.
Punished. Yeah.
Correct?
Correct.
Same rule. Whether you make the necessary change or not, you should not make unnecessary change. That is why hypothesis testing comes. That is why a rule comes to make sure the risk of making unnecessary change is always limited to 5%. You make sure the risk of making unnecessary change is always limited to 5%. So this is what we check in hypothesis testing. We conduct experiment, we collect data, we calculate some statistics, we understand the uncertainty. What is uncertainty? The risk. If the risk is less than 5%, only then I reject the null. Right? So there is a tool which can measure this risk. There is a tool which can measure the risk. You know what is the tool? The tool is known as p-value. The tool is known as p-value, which is basically a probability.
Probability value.
It is basically a probability of you
Event.
committing type 1 error. What is type 1 error? Rejecting?
True. True
Rejecting,
null.
rejecting a true null hypothesis.
Right.
So always the permissible risk is 5%, not more than that. This is what we call it, alpha risk. We call it as alpha risk. Other name is, this is also known as level of significance. All right. Hope whatever I typed on in the Excel sheet, you are able to understand. Am I correct?
Yes.
Yes, sir.
All of you are very good with hypothesis testing basics.
Yes.
Yes. 1 minute. So now I have to take you through my slides. Okay, module 1 over, module 2 over. We have to go to module 3, analyze. So any questions you want to ask, please feel free. I'll be happy to answer. And today's plan is to only make you comfortable with the basics of hypothesis testing. And tomorrow morning, we will teach you, some case studies. Then in the afternoon, improve and control is a lighter stuff. And that will complete your green belt cycle of learning. All right. So all this you have discussed. So what is hypothesis testing? Right? So what is hypothesis testing and what is null hypothesis? What is alternate hypothesis? Hypothesis testing is nothing but a validation procedure, right? A procedure to validate any claim. What is hypothesis testing? A statistical procedure to validate any claim or any statement. So the claim is always about two scenario or multiple scenario, isn't it? With the coach, without the coach. Coach A versus coach B. Team A versus team B. Process A versus process B. Machine A versus machine B. Supplier A versus supplier B. Or supplier A versus B versus C versus D. These are all the situation you come across. Am I right? Maggi versus Yippee versus Top Ramen. Which noodles contains the lower lead content? Now I have a doubt, isn't it? My doubt is maybe one of the packet may have more lead content. I don't want to consume. Isn't it? Now what is my null hypothesis? The lead content are equal. What is null hypothesis? Lead content are equal.
Equal.
Then what is alternate? Lead content are unequal. Or the lead content in Maggi is higher. Or lead content in Yippee is higher. Or lead content in Top Ramen is higher. Or I can also say the opposite. Lead content in Maggi is lower. These are all alternate. When I say higher, lower, not equal to, these are all alternate. When I say equal, the statement is null. Whether the training is really having an impact on your ability to solve real-time problem. That is also a statement, isn't it? Some people are really interested in knowing it. Hey, you have done Six Sigma training. Is there a real improvement happened? And now, what is the null hypothesis there? No improvement. You are exactly same before training and after training, no impact, nothing happened. It has gone through this side and then gone out this side. Nothing absorbed, no change. This is null hypothesis. But some people have the habit of internalizing everything they learn, they hear, and then, achieve excellent results. They are now able to implement better. When I say now they are able to handle problems better, their skill levels really has gone up. That means the statement is alternate. Isn't it? And you normally you don't require any evidence to prove the null. If you simply say, sir, training made no effect in my skill, you don't have to prove because everybody is ready to believe. But if you say, sir, the training is fantastic, sir, I really learned a lot of principles, a lot of new tools. Now I'm you are seeing my better version. Oh, really? What kind of results you got? They will be asking, interested in knowing some, evidence. Oh, really? Show me. Now, if you show, yes, sir, I have done 2-3 projects. See, look at the way the project is documented. Look at the way I am handling the tools. And now, yes, really, it is good. So, for alternate hypothesis, people always, expect some evidence. Please note in hypothesis testing, we have not started working on alternate. We have started working on only null.
Null.
We either final conclusion is we either reject null or we don't reject null. Isn't it? If somebody asks you, hey, the training has really made an impact or not, then what will be your answer?
Null hypothesis, yes.
Yeah. Null, you will reject the null or you will proceed with the null one?
Reject the null.
You will reject the null. Hey, what you are seeing is not the old man. It's not your old friend you are meeting now. You are seeing the better version of your friend now. Isn't it? So that's what you are trying to say. So if you say that you are not the old one, that means, you have, that means, you are rejecting the null. Right? If they are seeing the same person, that means you are not able to reject the null. So this is what.
Sir, is my understanding right? All the statements are null and all questions are alternate hypothesis?
We can't say that way. We need to know what are those statements.
Okay.
You read the statement, and then if the meaning is conveying an equality, conveying no impact, conveying no difference, then it should be called as a null.
Anyways, that would qualify to a statement or an answer, na? Having no significance.
Statement, we can't simply say all statements are null. No. The meaning of the statement makes it null or alternate.
Okay.
All right.
Okay.
So a claim about the difference between two groups or any number of groups, you can test it for the trueness. Is there real difference exist? That procedure is known as hypothesis testing. It is a statistical procedure where we conduct experiment, generate data, and then with the data in hand, we try to measure the uncertainty in our decision. We try to measure the uncertainty. Uncertainty is nothing but standard deviation. Uncertainty is nothing but standard deviation, the error in believing the average. We simply say that no, we always make a conclusion using the average. But average is one number which is calculated using several numbers. Right? And if those several numbers, if there is a variation, if the variation is too much, then average will start losing its meaning. That standard deviation we measure and then we conclude the amount of uncertainty. If the amount of uncertainty is more than 5%, we better don't take any decision using such data. If uncertainty is lesser than 5%, then only we take decision. All right. So it's a decision-making procedure where a claim about the difference between two or more groups is validated. Look here, lot of statements. Now please tell me, is all these statements null or alternate? You see here after brainstorming, your experts are telling like this. Reaction time affects the process yield. Is it null or alternate?
Alternate.
Alternate, H1. Pouring temperature will affect the casting quality.
HO.
HO
Alternate.
This is, see here, there is an effect. Can you see? It is written straight away. It affects the casting quality. Affect means there is an effect.
More.
Yeah, it's an alternate. All are alternate. So null means statement of no impact, statement of equality, statement of no change, or statement of no difference. The dead opposite is alternate. Right? And now I make a statement. Tell me, is this statement null or alternate?
Alternate.
Alternate.
Very good. This statement, calorie consumption will
Alternate.
Alternate.
Speed of the car will affect its mileage.
Alternate.
Alternate.
Reaction time will affect the process yield.
Alternate.
Alternate.
Very good. All of them are conveying statement of impact. Pouring temperature has no effect on
Null.
the
Null.
calorie consumption has no impact
Null.
on your weight
Null.
gain.
Null.
You know that calorie consumption can can impact your weight. That's an innocence, isn't it? That's why null hypothesis is always a statement of innocence. Sometimes your company innocently believe wrong things. All right. So speed of the car has no impact on its mileage.
Null.
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 Reaction time has no impact on process yield. All of them are statement of no impact, so all null hypothesis. Supplier 1 deliver faster than supplier 2. Now you are comparing two of your supplier, saying that one is better.
Alternate.
Alternative.
Machine 1 is better compared to machine 2.
Alternate.
Alternate.
Loading rate of northern region
Alternate.
better than
Alternate.
southern. Transaction time of the vendors are not equal.
Not same. Alternate.
Alternate.
Same or statement of inequality. You are saying one is better, one is not better. So delivery time of supplier are same.
Null hypothesis.
Null hypothesis.
Your company believes that both the suppliers are performing at the same level.
Same
They have
level.
two suppliers, isn't it?
Yes.
Yes.
So this is your all your current beliefs are nothing but null only. Machine 1 and machine 2 produce at the same rate. Null.
Null.
Or equal. Null.
Null.
Time of vendor are equal. Null. You will be able to find the statement null and alternate. So any experiment you do, I think you will definitely be able to make the null hypothesis and alternate hypothesis in the correct manner. Yes or no?
Yes, sir.
It's not just by using the correct English. It is writing the statement in a way that it conveys the required meaning. That is also important. Do you understand? If you write a statement but if it conveys an impact, then it should be an alternate.
Alternate.
If it doesn't convey an impact, then it is null. If there is an impact, and that means the factor should be the root cause, critical. Only critical factors will have the significant impact. All right, now type 1 and type 2 error. Do you remember? I have already taught you type 1, type 2 error. What is type 1 error?
Type 1 error is nothing.
Null.
Rejecting the null
Null.
hypothesis.
True, null, rejected. Null, true, but rejected.
Rejecting a null
But
hypothesis.
a true null hypothesis is
Type 1.
Rejected.
then what is type 2 error?
Null hypothesis false, but we accepted it.
False null is accepted.
Accepting a false null hypothesis. In a manufacturing scenario, imagine the product produced is good, but the item is rejected. What is the error we committed? Type 1.
Type 1.
Good is rejected as bad. Sometimes bad will be accepted as good. Accepting
Type 2.
bad as good is type 2 error. All right.
Yes.
Then there are two more terminology: confidence level and power of the
Power of
test.
test.
What is confidence level? The confidence level is your ability of your test to accept true null hypothesis as a true null hypothesis. Accepting true null hypothesis is confidence level. Null hypothesis is true and you are accepting it. That is known as confidence level. There is one more thing, power of the test. Null hypothesis is false and you are able to detect it correctly. That is called the power of the test. The item you are inspecting is bad and your inspection has got enough power to detect it. All of you understand what is confidence level and what is power of the test? With the physical, there are different scenarios. We use the same terminology. Type 1, type 2 error. In manufacturing, a good product is rejected as bad. That is type 1 error. Am I right?
Yes.
In hypothesis testing means it is for the statement, not for the products. Product can be good or bad, but statement can be true or false. Yes or no?
Yes.
You replace the word with, good with the true, bad with the false. And replace the word product by the word statement or the hypothesis. And the hypothesis is always null. Null hypothesis is true, but I still reject it. What is the error I am committing?
Type 1.
Null hypothesis is false, but still I am ready to accept it.
Type
After
2.
Type 2.
Type 2.
committing type 2. Whenever you do the hypothesis testing, these errors will happen. You have to make sure the type 1 error is very, very sensitive, very, very important. Because the type 1 error will affect the company, isn't it?
Hmm.
When type 1
Yes.
error means null hypothesis is true, but you still reject it. That means you are making necessary change or you are making unnecessary change.
Making unnecessary change.
Company will be very sensitive if you commit type 1 error. You know that already. So always in hypothesis testing, type 1 error should be less than 5%. Type 1 error should be less than 5%. This is known as level of significance. Alpha risk. This is known as level of significance or alpha risk. What is the permissible alpha risk allowed? 5%.
5%.
Sir, actually both are critical. Na? Type 1, type 2, both are critical only. If you are
Both are
rejecting
critical.
okay also, it's a critical. But accepting
See,
rejecting
company's belief is wrong. But you are not opposing. Company is not worried right now. Isn't it?
Okay.
Imagine there is a wrong practice going on in your company. Why it is going
Okay.
on? Because they don't know it is wrong. And you are also not opposing. Do you think somebody will question you? Hey, why you are not telling us? No. Am I correct or not? But if I teach you something wrong, if I don't teach you certain tools, you are not going to be worried. But whatever tool I am teaching, if I teach in a wrong manner, then you will certainly be worried. Yes or no? So type 1 error is more important to your company than type 2 error. Am I correct?
Sir, can I come?
First of all, participants, am I correct?
Yes, sir. Yes, sir.
That's all. Yes, sir. Now you can add.
Yes, sir. Gentlemen, it depends upon the person
Sir.
also, perception. Like, for example, you are buying an item. Your wife is asking you to buy some rice. And you want the rice to be good rice or bad rice.
Good.
So
Of course,
type
sir.
2 error is more important. Right?
Yes.
You don't want to accept a bad rice. You want to accept a good rice only. Yes or no?
Yes.
Yeah. Suppose I want to sell a rice. I'm selling a rice. I do not want my good rice to be rejected by you. Yes or no?
Okay.
I'm making a good rice, yeah,
Good
and you are rejecting as a bad rice. I don't want that to happen. Type 1 is more important for me. Yes or no? Similarly, in a hospital, patients are coming. Now he is having a cancer.
Yes.
Now doctor should say he is having cancer or he is not having cancer. Right? If he is not having cancer, then what you should say? He is having cancer or he is not having cancer. So in both the
Not
cases, this
having.
is very important. So depending upon the situation and depending upon the position you are in, type 1 error, type 2 error, both are important. That is nothing but a contract between the supplier and the purchaser. Thank you.
Yeah. Different scenarios, yes. But then from the, the manufacturer's point of view, they fix a value for the, the alpha risk. Alpha risk should be less than 5%. That means the required confidence level is 95%. Similarly, the type 2 error is known as beta risk. Type 2 error is known as beta risk. For that also, yes, as RK sir said, they will set a value for type 2 error also. If type 2 error, let us say they fix it.
We fix the power rather than the opposite, the other way of it.
Yeah.
Like confidence
Type 2
and
error,
significance we are saying, there we are saying power and significance. Yes.
Yeah. If the permissible type 2 error, which is known as beta risk, if that is 10%, that means my power is 90%. All right. So imagine you have to buy a rice for your family because your wife, gave an order. that you should buy a rice bag for 1 month, right? So 25 kg rice bag you are buying. So you went to a nearby shop and then you wanted to purchase the rice bag. You do some study, right? You do some experiment before buying,
Yes, sir.
right? Otherwise, your wife will question you, isn't it?
Yes,
What is
sir.
this? Yeah, you are a quality manager and you did not buy a good rice. So you will do some study. You take some sample, you will take some sample. And then you will study the sample, and if everything is good with the sample, what do? You take the whole bag. You will buy the whole bag, isn't it?
Yes, sir.
But instead of you studying the sample, your bad time, the lot you purchased may be bad, isn't it? That's the time you will be scolded by your wife.
Yes, sir.
You don't even know how to buy a rice bag. I don't know how are you working as a quality manager in your company. Now, problem is, your sample has cheated you, isn't it?
Yes.
So that's why the quality of sampling is very, very important. So the rice bag is bad, but you still ended up purchasing even after doing an experiment. Now the error happened is type 2 error. Now consumer is getting affected. Isn't it? Consumer is getting affected. This is called consumer risk. A bad lot entering the market because of poor sampling. This is beta risk or consumer risk. But for your company, they will be more interested in manufacturer's risk. If you reject all the good lots by saying that everything is bad, then the shop fellow will be worried, isn't it?
Yes.
That is called type 1 error. So in hypothesis testing, you have to replace good lot by true null hypothesis. You have to replace the word bad lot by false null hypothesis. Do you understand how you should use the concept? You slowly do this experiment. You do it as a small assignment. Write down, when I say lot, sample, good part, bad part, it is easy to define. You define it. You write it in your notebook. And then next statement, you change the parts into or change the lot into null hypothesis. Good means true. False
Yes, sir.
bad means false.
False.
Then you will understand. See here, this table is illustrating what is alpha risk or type 1 error. You see here, good lot, rejected, alpha risk, which is also known as manufacturer's risk.
Manufacturer's.
If bad lot, see here, bad lot, still accepted, that is consumer risk, also known as beta risk. If alpha risk is 5%, then confidence level is 1 minus alpha, which is 95%. If beta risk is 10%, then power of the test is 90%, which is 1 minus beta. That means there is a relationship between alpha and confidence level, beta and power of the test. If alpha is 10%, what will be the confidence level? If alpha is 10%,
90.
very good, 90%. In hypothesis testing, I have written it for you. That is there in the course material also. You can see. Null hypothesis is true, but you are still rejecting it. That is type 1 error. Null hypothesis is true. You are correctly accepting it. That is your confidence level. Null hypothesis is false. You still accept it. That is type 2 error or beta risk. Null hypothesis is false. You are correctly rejecting it. That is called the power of the test. Do you understand now?
Yes.
You can read it.
Sir,
Clear?
one question from my side, Harish here. So there is one example like, failing student is passed by the examiner, or, the passing student failed by the examiner. So in this, type 1, type 2 errors are, from the perception point of view, like, from the examiner or from the student point of view, which one is, type 1 or type 2? A failing student passed by the examiner or a passing student failed by the examiner?
Okay. Suppose if I fail you.
Yeah.
You wrote well, but still we are giving you a lower mark. What is this?
Type 1.
So from the perspective, from where we are seeing, from the student's perspective or from the examiner point of view. So just confused,
I think here the result matters because we are rejecting the good one.
Yeah. You are rejecting the good one, correct? It's type 1 only.
It is type 1.
Got it?
You mean to say that passing student failed by the examiner is also a good one? Like, you know, it's a negative one.
No,
Is
no.
it called type
Come
1
on.
or type 2?
Type 2. Student who wrote the exam well, but still, you know, failing is type 1. And those who did not write well, but still we are passing is type 2. That means the bad product is going to the market.
Yes.
Yes.
All right. So, what is the quantum of type 1 error while rejecting the null hypothesis? There is a beautiful tool designed to predict that. That is called p-value, probability of significance. You remember I gave an example already, Virat Kohli's example, right? What is the probability for Virat Kohli's batting average to lie between 45 to 55?
90%.
95%. Because those are 95% confidence limit. So what is the probability for Virat Kohli's batting average to fall outside the confidence limit?
5%.
5%.
That 5% is known as probability of significance. Always we expect our statistics to move up to a certain limit. Am I right? Yes or no? You expect your, you know, fat level to be in a particular range. If you go to hospital, you take any, you know, report, they'll give the range. Am I right? You know how they have given the range?
Yes, yes.
According to a study conducted, they understood that at least 95% of the people's sugar level will be in that range. That means their idea is they want to convert 5% of the people into their customers. I mean patients. Am I correct? Always the odd man will be picked up. Am I right or not? Last 5% of the people will be given a brand name. They'll be called patients in hospital. In your company, they'll be called as bad products. Am I right? In our case, we will call them as weak students. Am I correct or not? So for everything, we can set the limit. We are upfront, we are setting the limit. That is called rule of the game. Here, what is the rule we have set? Anybody who is scoring below 60, we simply believe that, you know, they are not fit for the certification, isn't it?
Yes.
So we are setting our level of significance at 60. If you make your score go below 60, then we will consider that as a significant deviation. And then, you know, you will be asked to reappear the exam. Correct?
Yes.
Same manner for your process, you have to set such a level. And what is the probability for the data or the statistics to go beyond that set value? That is normally set at 5%. That is normally set at 5%, and we call it probability of significance. And the definition for p-value is given here. You all can read all the three statements, and if you could understand the statement, then you be good about your understanding. Because I have already explained you what is p-value, isn't it? What is p-value? The risk of you committing type 1 error while rejecting the null by believing the experimental data. That is written here. Can you see here? P-value is an estimate of type 1 error. Because why do I say estimate? Because accurate value is impossible in this world. Am I correct or not? We don't know how many years we live. Can any of you, can you tell me exact number of years you are going to live?
No.
We don't know. So but we can always give an estimate. That means there is uncertainty involved, right? And how much is the amount of uncertainty, right? Or what is the chance for we committing the type 1 error? That is called p-value, probability of significance. And now you can also read these statement, and if you could understand, that's well and good. Otherwise, you may have to read a lot of literature to understand all the definition. All of them are same. All of them are same. But now I have simplified to certain extent. All of you are clear?
Yes, sir.
The chance for Virat Kohli's average to appear outside the confidence limit is 5%. That means if I take a decision, I have seen statistics outside Virat Kohli's normal batting, but no confidence limit, and I assumed that the addition of the coach is significant to Virat Kohli's performance. But still, I can be wrong, isn't it? The coach should have simply enjoyed his, all his time in India, but still Virat Kohli could have improved the performance on his own. Possible or not?
Is it a chance of making an wrong assumption with a wrong observation?
Yes, correct. But ultimately, we wanted to limit the type 1 error to less than 5%, right? So maybe, we will deep dive in the p-value again after you internalize or digest whatever you have learned so far. So it is the p-value that will help you to take decision. Whenever you conduct an experiment, you collect the data, and then, with the help of the data, you calculate p-value. And for calculation of p-value, there is no mathematical formula. It is based on, a big table. It is based on a big table called normal distribution table or standard normal distribution table. There are two things, normal distribution table, another one is standard normal distribution table. In normal distribution table is based on average and standard deviation for any value of average and standard deviation. But there is one more thing called standard normal distribution, where the average is assumed to be 0, standard deviation is assumed to be 1. Do you understand? You remember I have shown you. You also calculated the Z score very correctly. How many distance from the center? 1 standard deviation. Do you remember?
Yes, sir.
For 3 sigma process, when I shown my cursor, you told me, sir, now we are at 2 standard deviation away from the center.
Yeah.
That means G score is 2. And now at the 3rd sigma level, your G score is 3. That means you can convert a real statistics into a standardized value known as Z score, Z score, isn't it? If you have any data, there will be some average. Any data, there will be some average. And there will be some standard deviation. So, in your histogram, always in the x-axis, you will have your CTQ written. Am I right? If you plot a histogram, the x-axis will be your CTQ. CTQ may be, the call handling time. CTQ may be call handling time. But every x variable can be converted into a G score. You remember that exact same example, car arrival time. I converted that into Z score. I have shown you Z score of 3, Z score of 6. Isn't it? When I say Z score of 6, what does it mean? I am at a point which is 6 times standard deviation away from the center. Correct? When I say a Z score of 3, I am saying that my center is, the distance between my center and the point is 3 standard deviation. When I come to the exact center, what will be my Z score?
0.
0. Very good.
0.
In a normal distribution, the center will be average.
Average.
But in a distribution of Z score, the center will be Z equal to 0. Do you understand now?
Yep.
So, if the center is assumed to be 0 and standard deviation is assumed to be 1, the distribution is known as standard normal distribution. This understanding is important, to generate solution for any kind of problem. You will slowly, understand that. So, now p-value is calculated, with the help of data. Whenever you see a p-value of lesser than 0.05, you can reject the null hypothesis. You can reject the null hypothesis. That means it is similar to a scenario of observing your statistics outside the confidence limit. If you see your statistics outside the confidence limit, will you believe that the addition of the coach has made a significant result? Yes, isn't it? Hence, the effect due to the X factor is considered significant. That means the X factor you are studying is definitely a root cause. I am at least 95% confidence on that, right? Similarly, if p-value is more than 0.05, fail to reject the null. You see here, look at the words. We are not saying that accept the null. We are saying that fail to reject the null. I know my company's belief may be wrong, but only thing is I am not able to reject that. I did an experiment, but my experiment did not give me enough confidence to reject it. So I am carefully saying that I failed to reject the null. Please note, all of you, practically whatever way you want to decide, you take a decision, because rejecting the null is as good as accepting the alternate, isn't it? But if you are writing down, if you are writing a report for a purpose, you have to use the same language. Otherwise, you will be in trouble later on. Somebody will come and question you. 100 questions they will bring if you write. So speaking is no problem, but then when you are writing, you have to use the same terminology, same language, right? So if whenever p-value is more than 0.05, that means the statistics observed is still inside the confidence limit only. Under such situation, don't consider your findings as significant. Even though your data is giving some information, don't believe the data. Now we are teaching you a way by which you exactly know when to believe the data and when not to believe the data. Do you understand what I'm speaking?
Yes, sir.
Earlier we told you be data driven, but now we are telling you at times you should not use your data. Am I right? Particularly whenever p-value is more than 0.05, it is better not to refer to the experimental findings. Keep quiet. Right now, you don't have enough evidence to make any conclusion. That's the meaning. Hope it is understood by you, all of you. So far, good?
Yes.
If you really feel good,
Yes, sir.
you are a significantly better Six Sigma expert from any other source.
That is alternate type.
Otherwise, they all will carry a certificate, but can't talk all of this. But now, in addition to the certificate, you have got something else also with you. You can better confuse anyone, right? So you have got that power now. So you are a Six Sigma expert now. So now, depending on the scenario, there are various hypothesis testing. In order to understand the scenario, you should first understand what type of data your Y variable is. Do you understand? In order to choose the right hypothesis testing, you got to find out what type of data your Y variable is. You might look at the scenario. A cooking oil manufacturing company, they claim that the fat content is 15%. So what is that the company is believing? The company believes that all their food packets have exactly 15% fat content. That is their belief. Am I right? That is why they have printed in the food packet or the cooking oil. And now imagine you are a dietitian or an external doctor who want to recommend this cooking oil to all your clients who are basically patients. And you don't want to take the risk of recommending a product which is having a higher fat content or lower fat content. You want to recommend a product which has a fat content slightly plus or minus 15% fat content. Do you understand? But when I say slightly, sir, how much can be considered slight? That is where you require confidence limit. Sometimes, several centimeters away may not be significant. Sometimes few millimeters away may be significant. Am I right or not? We don't know when to say, several centimeters are significant and when to say a few millimeters are significant. Because we don't have the domain expertise. Isn't it? In terms of diameter, product diameter, I know in any manufacturing company, they will talk, mostly in terms of millimeters. Sometimes they even go to the extent of microns. I know certain things, but some other domains, for let's say medical parameters, I don't know. But still, which is significant and which is not significant, statistically I can predict and better guide people. The person may even be a medical doctor, but I can still guide him on which is significant and which is not significant by using the statistical method. So saturated fat content is 15%. And now in order to understand whether all the products are really having a fat content close to 15% or significantly away from 15%. Anything close to 15%, I am okay with it. I will recommend to all my clients. But anything significantly away from 15%, I don't want to take the risk because there are many other products. Agreed? Now, what will I do? I will buy a sample of cooking oil from the market and test them and see how much is the actual fat content. Let's say I take 10 sample and so I have 10 readings. After having 10 readings, what can I do? I will see the average fat content. Am I right? I will see the average fat content. I can also study the variation in my 10 readings. Should I study or not? If I look at the average, I get an idea whether the product and the specifications are same or not. But when I look at the variation, if the variation is too much, I will lose my confidence on the average. If the variations are less, then my confidence on the average can build several fold. This is what we are doing in hypothesis testing. If the variation is too much, p-value will be more than 0.05. P-value and variation, there is a connection, right? So the variation is converted into p-value. Right now, reserve this question, how the variation is converted into p-value. I will show it little later, and then you will be convinced about p-value also. It can be calculated. You have to become little familiar with the Minitab. I'm sure all of you have installed the Minitab and then ready to learn Minitab also when it is start. Probably the coming Thursday, I'll show some, spend some time with the Minitab. And then you yourself will be able to calculate p-value. So when p-value is lesser than 0.05, you can take decision using the experimental data readings. If p-value is more than 0.05, better don't take any decision, right? Don't take any decision. So now this particular testing is known as one sample test. This test is known as one sample test because we have taken a sample from the market. Sample can be a group of sample units. Please understand. Sample means subgroup because you purchased 10 cooking oil bottles, isn't it? 10 bottles you purchased at a time. All the 10 collectively is known as sample. Or it is better to use the word subgroup of 10 samples. Here, all of you, this test is known as one sample t-test. You are a doctor, you collected samples from the market, but what is your intention of study? Can one of you tell me what is your intention of study? Is that your interest is to study only the 10 bottles, or do you want to understand all the cooking oil that is manufactured by the company?
To confirm the confidence level of 95% of all the cooking oils from these 10 samples.
You have collected a sample and you have studied it, but your intention is you want to understand the quality of the cooking oils produced by the company. That means you want to understand the population, but population you will never be able to see together. Because the company produces millions and millions of cooking oil bottles every single day, and every single day it is going to the market. And nobody can see the population at a time. Isn't it? But the characteristics of the population I want to know by studying a small set of sample. This is called one sample test. The test is specifically called as one sample t-test because my data type is continuous. Saturated fat is measurable. Am I right? So data type is continuous. And since there are 10 samples, I take an average and then take a decision. Whenever my data type is continuous, I take a decision using the statistics known as average. My test is known as one sample t-test. For the same situation, you can perform one sample g-test also. But in order to perform one sample g-test, you should know the characteristics of the population. You should know the characteristics of the population. Do you think the company will share the characteristics of their product? They'll only print some value and then show you. But the reality, they will only know. If the real values are nothing but the population parameters, what we calculate is statistics from the sample. What we want to understand is the characteristics of the population, which are specifically known as parameters. Nothing but the population average, population standard deviation. If population characteristics, particularly population standard deviation, is unknown, you can only do t-test. If population standard deviation is known, then you can do g-test. All of you understand when to perform one sample g-test or one sample t-test? What are the requirements? Data type must be continuous. Your y variable must be continuous. And decision making statistics is average. If population standard deviation is known, we go for g-test. If population standard deviation is unknown, we go for t-test. Now imagine there are two cooking oil companies, cooking oil company A, cooking oil company B. Now your doubt is which cooking oil has more saturated fat. Now null hypothesis is fat content are equal. Alternate hypothesis is fat content of A is more than fat content of B. All of you understand the statement now?
Yes.
Now you are comparing two samples. The
Yes,
test
sir.
is known as two sample t-test. The test is known as two sample t-test. Similarly, you comparing two of your vendors. Which vendor is performing better in terms of transaction time? Or you are comparing your own children, a boy and a girl. Whether boy is performing well in mathematics or girl is performing well in the mathematics. Or your son or a daughter. These are all scenarios of two sample t-test. Because marks is a continuous data. Transaction time is a continuous data. Fat content is a continuous data. But at a time, if you want to compare more than two groups or more than two products or more than two suppliers, more than two machines, 3, 4, 5 or any number, the study is known as ANOVA. I have introduced 4 hypothesis testing. How many hypothesis testing? One sample g-test, one sample t-test, two sample t-test, and then ANOVA. What is the common thing you noticed? In all the hypothesis testing, data type is continuous. Have you seen that? And decision making statistics is average. When population standard deviation is known, only then we go for g-test. Population standard deviation is unknown, you have to go for t-test. T-test is less accurate. G-test is more accurate. Home food is healthier. Hotel food is not healthier. Right? So whenever home food is not available, then only we go for hotel food. Whenever population standard deviation is known, we will only perform a g-test. But if it is unknown, then only we go for t-test. Hope it is clear so far, all of you. All the 4 are commonly known as test of averages because all of them study the average, use the average. So in this manner, I bring you here. Test of average, how many tests is available? You see here, one sample g-test, one sample t-test, two sample t-test, ANOVA. You all know the scenario, right? Instead of checking the average or comparing the average, sometimes you may want to compare the proportion. You know what is proportion? The percentage of items rejected is a proportion. That is not average, isn't it? We calculate average if our data type is continuous. But we calculate proportion if our data type is discrete. All of you understand? The number of units rejected every single shift. The data is continuous or discrete?
Discrete.
Discrete. The number of people who are buying from my website. The number of people who buy from my website. Discrete. The number of leads my campaign can generate. Discrete. Isn't it? So some situations we take decision based on the percentage. That is known as proportion. You can always compare the performance of a group against a reference. Let's say I have a digital marketing campaign and normally the conversion rate is 6%. But your campaign, you are claiming that your campaign conversion rate can be better than the reference value. Reference value is 6%. And you are saying that your improved campaign can give a conversion better than the reference value. Now the test you are talking about is, or the test we need to do is one proportion test. We are talking about proportion, right? 6% is proportion. But you are saying that you have a campaign which can give a conversion better than 6%. That means it is one proportion test. Suppose you have a campaign and I have another campaign, and we do compare each other. I am saying that my campaign can give result better than you, and your campaign can give result better than you. Campaign result in terms of number of leads or number of conversion, they are all proportion. 1 proportion, 2 proportion. At a time, if there are three campaign, then it will be a new kind of test known as chi-square test. Why different name and different kind of test? Because it's a time-consuming procedure. If you want to do everything manually. So instead of that, these people have done a lot of research, and then they have given you a step-by-step method. You simply use their formula, and then you can take a decision. Ultimately, in all the tests, the final outcome is p-value. What is the final outcome? P-value. And if the p-value is lesser than 0.05, you have to reject the null. That means believe the experiment and take a decision. If p-value is more than 0.05, even after conducting the experiment, don't take any decision. Don't make any conclusion. Simply you say that you have failed to reject the null. That's all. That means you are not able to take decision even after conducting the experiment, right? So these are the tests. Similarly, you can compare variants. If you compare 2 variants, it is F test. You compare more than 2 variants, there are 2 options, Bartlett and Levin, any one you can use. Similarly, you can study the relationship between X and Y. If you study the relationship between single X and Y, then it is known as correlation. If you study a relationship between a Y variable and multiple X factor, then it is regression. That's all. So tomorrow we will learn all this stuff. One sample test, a case study, and everything. We'll see a case study. I think the basic foundation is laid properly. Am I right?
Yes, sir.
So wish you the best.
Yes, sir.
Yes, sir.
To understand more on the hypothesis testing, and tomorrow morning stuff is going to be very, very crucial, very, very important, and that is going to differentiate you from the average Six Sigma bells who are available in the market, right? So if possible, go through a similar stuff, maybe the material or any content that is available in literature. Try to internalize your learning. Try to digest more of what you learned today. Definitely, that is going to differentiate you. You will straight away, you will go to the top 5%. You will become, a significantly better Six Sigma expert. No doubt. 100 profiles can come, but you will definitely be able to make an impression. Right? All the best.
Thank you, sir.
Yes, sir.
We'll meet tomorrow. Yeah.